Oh my gosh! Charot. Hello guys! So let's erase this writings in the whiteboard because I need to save time. So let's do this spontaneously. Okay? Things like that. Okay. So we now go to problem solving. Okay. So this is gonna be our problem solving. Wait. So I have researched a lot, okay, for our problem solvings tonight. Okay. So I have 4 questions here. The number 3 is like a theory questions. It has to do something where previous regarding the topic of, intermolecular forces, the polarity, non-polarity, okay, paramagnetic, okay, and diamagnetic substances, things like that. Okay, got the point? Okay, let's erase this, no? So, okay. So in this way also, you are also careful with your cell phones, where to put, because you know already the characteristic of the fluids around you. Things like that. So, for example, you have alcohol in your home. Then you know that alcohol is highly non-polar, like that. Things like this, and then it is flammable. Things like that. So I will not contact my blah 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 so and so. So that's why it will be applied. Okay, things like that. And another also, so you need to extra careful what are the substances in your kitchen, and you will not be able to mix that. Maybe it will explode also. Things like that. You get the point? Okay. Diba? So we can classify substances now in our kitchen according to its, behavior, physical and chemical properties. Because this is not limited only to science professionals, chemists, chemical engineers, physicists, like that, biologists, metallurgists, okay, the scientists, okay, world. Okay, it's also applicable to other people, generally, the basic of science, right? Okay, so let's go to our problem solving number 1 chart. Okay, so I will read first, then I will write. Okay, the solubility of carbon dioxide in solution is 0.003 molarity at 2 atmosphere. What is the solubility of carbon dioxide at 6 atmosphere? The temperature remains constant. Okay, so as you can see, the Henry's law also will behave like a Boyle's law. And then similarly, will behave also like an isothermal thermodynamic process in the first law of thermodynamics. Okay, things like that. Constant pressure also. No, constant temperature. The temperature doesn't change. Okay, so that's how you connect. Okay, so isulat dari Ari. Okay, so number 1. The solubility, okay, like that. Okay. Take note, there's a general chemistry. The solubility will always not be used, Instead they will use molality, concentration. But if it will be used there just to trap and trick you. Okay, but it's the same. Because you don't normally use this terminology, some students also examiners will be a little bit panic because it's not applicable for that particular category. But we need to remember the synonym, okay, the same meaning of the particular terminology, okay, things like that. It's very useful in chemistry and physics. Okay, get the point? And another clue also, guys, the reciprocal of something. You should also learn that. For example, if you will reverse the unit of that particular quantity, and what is that after? So there's also another meaning for that. Okay, things like that. So you need how to classify what is a molar volume, and specific volume, and a volume, natural. Okay, because these three don't have the same meaning. Okay? Things like that. So you can also distinguish what is a molar flow rate, okay, a molar flow rate, a mass flow rate, and a volumetric flow rate. Okay, so most of the engineers really are taking that as general. So dito na magdaog sa unit. But if we want to be precise, we need to understand really the distinction between one over the other. Okay, it will help us a lot to understand further. You get the point? So you will not convert that much, whatever. Okay, get the point? Okay. The solubility of CO2 in solution is 0.003 molarity. Molarity meaning molar, then the symbol will be capital M. Okay, at 2 atmosphere. Okay, like that. What is the solubility? Okay. Sometimes guys, question like this looks like difficult if all subjects are mixed together in one day of examination. Because you know, it's very difficult to categorize there, like that, okay? So if you can relate what I mean, okay? Things like that, because it's already compressed and combined. So what really left there is your total comprehension, your learning outcome, things like that, because it's already mixed all. Like our prelims, midterms, finals, that we are going to take prelims only in this particular subject, like that. So it's easy for us to study, right? But once it will be combined together in 3 days, all the subjects from first year college to fifth year college, it looks like strange, right? You get the point? Even though how hard we study, still there's also confusion somewhere along the way. If you can relate what I mean, okay? Mag-ibo ba ng mga Zuma cum laude, kitapakaha. What is the solubility, okay, of CO2 at 6 atmosphere? Okay. The temperature remains constant. Remains constant. Okay, what do you mean by the temperature remains constant versus the temperature is constant? Why one thing remains? There's also constant. Supposedly this is redundant, right? Once it remains, it's constant already in English language. Why? Because not all the time that it is constant in the initial stage, in the final stage. It's only constant in the initial stage, but not constant in the final stage. It's also constant in the final stage, but not constant in the initial stage. So that's why the temperature remains constant, meaning all throughout the way, from initial to final, from input to output. That's why the problems will always say remains constant. That's the difference upon saying the temperature is constant. So you need to extract what particular temperature is constant in that particular scenario, the problem. So we will take note that punctuation marks. Where does it ends? And then your parameters will be there only. Okay? Your conditions will be there only. So usually the problem solving are compound sentences and complex sentences. You will focus where it ends. Okay? So if there's no conjunction, for example, similarly, like don't carry the first parameters to the second paragraph, that would mean not the same. But if there's like that likewise, we need to say this still the same compound will behave the same parameters in the first paragraph. Okay? This is also sometimes we confuse because we normally ask for something pa in the next paragraph in which the English matters there. Okay? Furthermore, like blah 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 so and so afterwards, the ammonia will blah 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 so. We can say the same behavior, blah 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 so and so. Don't wait for the other adjectives in the second paragraph, the third paragraph, because not all the time will be phrased like that. Okay? So that's why it's very important that you need to build a solid foundation in English language when you take the examination. Okay, things like that. It matters also. Even though grammar only, that's very good. Grammar, because grammatically correct, phrases like that. Because in the examination, you are not told to speak, right? You are going to read, but you are not told to speak, and you are not also told to write an essay or whatever. All you have to do is to read and answer, read and answer, read and answer, right? Things like that. So you are testing your eyes and brain. Okay? Eyes and brain. But you are not testing your ears and mouth. You get the point? Things like that. Because that is not oral examination. It's all about the brain, the eyes. Okay? Things like that. Okay? More na siya natabo. More on cognitive. Okay? Cognitive ability. Okay? Things like that. Okay, now, the solubility of CO2 in solution is 0.03 molar at 2 atmosphere. What is the solubility of CO2 at 6 atmosphere? The temperature remains constant. Now, temperature remains constant, it could be either isothermal, thermodynamics, ideal gas law, it could be the Boyle's law. Okay? But, take note, there's solubility mentioned. 2 times repeat solubility. Klaro kasi Henry's law. You get the point. Now, since there are initial and final, you could not use the simple equation ng linear lang. So you are using the point 1, point 2 equation of the P1 or P2 because there are initial state and final states. Things like that. Okay? So, let's see. P1 over P2 is equals to S1 over S2. Like that. Okay. Actually, guys, no, you can solve this variation proportion by simple. If the solubility of CO2 is 0.03, like this, and then if the solubility of CO2 is nothing, and there's atmosphere, so what is the unknown pressure of that variation proportion? Algebra. Let X the unknown of, or let X the unknown solubility of CO2 at 6 atmosphere. So variation proportion, let X that. So, ganon. Very easy, right? Okay, but we need to follow the formula lang talaga dyan, no? Ni Henry's law. Okay. Pressure 1, check. To atmosphere. Pressure 2, check. Okay. S1, check. S2 is what we are going to find. So, solve S2. S2, okay, divided by, okay, times P1. Okay, S1 times P2. Solve for S2, right? So divided by this by P1 or cancel P1 divided by P1. So it's gonna be S2, S1 times the ratio of P2 and P1. So what is your solubility in S1? So 0.03. Okay. Pressure 2, or 6 atmosphere. Okay. Pressure 1, 2 atmosphere. Cancel atmosphere, 6 divided by 2 is 3. 3 times 0.03. Pila siya. Klaro in 9. Even though you will not use the calculator, it's very easy. It's 9. See? Okay, 3 times 3, 9. Okay, and there is 3, 0. Okay, so you will move that there in the right, I think so. But let's check the calculator. According to the theory in the math, you need to move that to the right kasi. Okay, if you deal with 0, 0 something in your multiplication, let's check it's 9 back. So, okay, 3 times 0.003. Okay, see 9 times 10 to the negative 3. Okay, okay, so 9. So, dua ka 0. So, 1, 2, 3. So, 9 times 10 to the negative 3. So, mo na siya ang imong molar. Okay, at 6 atmosphere. Okay. Now, guys, we need to use the proportionality also. This is the first, first style or first version or first solution. Okay. Tanawan ko ba ko 9 times 10 to the negative 3. Okay. For example, so let's analyze the problem in this way. Okay. So for example, if I have a partial pressure of 2, okay, atmosphere, it will yield 0.03 molar. Okay. Now, at 6 atmosphere, what is the molarity X? So let X, the solubility of CO2 at 6 atmosphere, then ratio and proportion. So X over 6, 0.003 over 2. Kuha gyapon siya, sure ko. Okay, so let's multiply. Okay, ana siya, no? So, di ba? So, 0.03 times 0.003 times 6 is equals to divided by 2. See? 9 times 10 to negative 3 is just the same. This is method 2, ratio and proportion. Method 3 will be the stoichiometric analysis, industrial stoichiometric analysis calculation. Okay, meaning amounts. Okay, for example, if I will say at 2 atmosphere, we will yield initially at 0.0003 molar. Then at 6 atmosphere, what is the molarity? Question mark. Now take note the gap from 2 to 6, it will be trifold, right? So 2 times 3, 6 atmosphere. Now, since the theory of Henry's law, the solubility and the partial pressure of a gas are directly proportional with each other, dependent. So we can also say the molarity is trifold by 3 also. Right? But don't do this if they are not directly proportional with each other. What do you mean for that? This will increase, this also increase. If this decrease, this also because this is not applicable. Okay? The ratio and proportion will hold only if they are very directly proportional. Okay, in the same manner. Okay, at the same quantity and at the same manner. Okay? So, mag-interpolate mo, interpolation. You get the point? Things like that. So, 0.003 times 3 mo paghapon. Yes, pareho lang siya. So, there are 3 versions how to solve this problem. Number 1, by formula, by Henry's law, initial and final state. Second, by industrial stoichiometry, okay, quantifying the amounts, okay. The third will be ratio and proportion by algebra, or the basic math, okay, things like that. Okay. Question number 2. Okay. Question number 2. The solubility gas constant, at 20 degrees Celsius is, okay. Usay siya tricky po siya nga guys ng question. Guys, I don't solve because there's no challenge anymore. Okay? I'll just pick up the problems and then get the answer. If it matches, then I'm correct. Okay? Because it's not good to solve repeating again, repeating. Okay? So that is not true learning. You get the point? Okay. Number 2, the solubility. If I'm wrong, I will just say to you, right? How many times I'm also wrong? So this is to be honest, okay? Because the more we do this, the more we are really not faking ourselves. For example, other vloggers always, because they practice a lot, they adapt a lot. Meaning to say that is not their natural ability. Because they adapt in order people to be to have a trending views just for the sake of money, like that. So to the point that they will say you are genius, you are intelligent, you are flowing, but actually you repeat that before uploading. So that's not, I don't want like that because it's not a challenge. I want my vlog not scripted. Okay, I want my vlog not prepared every time I will speak like that. It's always verbatim. Verbatim talaga. Spontaneous. Okay, things like that. The solubility, nakakaloka. Yung terminologies ko, verbatim yun. The solubility, gas, constant. Okay. Maabot ko tayo sa kwan guys. KSP, kulang sa pansin. What that is mean? Solubility, product, constant. KSP. In chemistry. Okay. At 20 degrees Celsius. Do you think that that the KSP have no other meaning. We have also another meaning in chemistry, that is solubility product constant. But in normal way of saying that as Filipinos, that is kulang sa pansin, right? At 20 degrees Celsius is 1.5 times 10 to the negative 3. Guys, kanina ano dito? Okay, so mole, wait ha. Okay, mole letter negative, things like this. You should be careful with this also ha. 1 atmosphere negative. Then we need to interpret now. Okay, this means this letter will be going to the denominator. And also, the atmosphere going to the denominator. This dash here between the liter and the 1, it's not product. It means division or in the denominator. Me also, when I was in first year college, I also analyzed this as times. But as I grow, studying a lot, like I found out that this is not really product. This is division. Okay? Both of them will go to the denominator. Ganon. Okay? The mole will remain in the numerator because there's no negative 1. Just like saying, mole negative 1. 1 over mole raised to the power 1. For example, we have 2x negative 1. So 1 over 2x raised to the power 1. If we involve variables in polynomial topic in algebra, right? Monomial, binomial, trinomial. So we will study the expression, the order, the terms, algebraic expressions, right? And the variables. We need to understand what are the variables of x, y, and z. What are the order of exponent? What are the expressions? 1, 2, 3 that involves those variables. Ipunin mo, 1, 2, 3. So equation, linear. Linear, there's no exponents. Okay, if there's an exponential, that's no longer linear. Things like that. You got the point? Okay. So you need to know that also basic in math, huh? Okay. So, what is the gas solubility? Okay. Guys, when we mean of gas solubility, this could refer to the compound element that has been mentioned in the problem. The gas. Like that. Because in Henry's law, we are only taking into account the gas. Okay, the pressure of the gas in the liquid and the solubility of the gas in the liquid. Okay, very clear, right? What is the gas solubility at a pressure? So this is a strange unit of at a pressure of 500. Guys, this torchuba chucho, this is very common for college engineering, right? Then, so we need to familiarize these 4 types of units of pressure. We have the 5 or 6. Torr, bar, psi, pound per square inch. Okay, like that. Pascal, kilopascal, atmosphere, mmHg. Now, 1, 2, 3, 4, 5, 6, 7. There are 7 units of pressure and you have to choose according to the problem solving. Okay, here, 500 torr. And the torr will not be compatible to the unit here because atmosphere. So, the first thing to do is you need to check the compatibility of the units because you will be wrong. Especially if you try to substitute directly without carrying the units and you cannot cancel that and you cannot simplify that further. So for me, the best way to do that is convert first. Not in the end. That's my style when I was in college. Not in the end. I will convert first, really. Okay? And then put that individually. Because mulubog siya, hugaw kay tanaw, masayop ka. Okay, get the point? Things like that. Okay, no. mmHg, millimeters mercury. Mercury is known to be a metalloid or can act as a liquid, can act as a solid at a certain temperature. Okay, that's why this is used as a measuring device to measure the pressure of our blood. So the unit, if we mean 180 over 90, this means 185 mmHg over 90 mmHg. So because the pressure is not unitless, pressure is always having a unit. But you know, we are practicing without saying the unit because it's understood. Then if you will ask anybody, can they answer what's the unit for that? Okay, so we need to be precise and technical in understanding. And we need to teach our children in this way, to be highly scientific, because we always hear that every time in the hall, in the school. What is your BP? 180 over 70. 180 over 70. So if you try to be strict, that's only number. Okay? Unless you will put unit, it will become a pressure. Correct me if I'm wrong. Okay? This is to be precise. Things like that. If you are very precise, you have to put unit. So, the unit of blood pressure is mmHg. Millimeters mercury. Millimeters is the distance height in which it will rise, it will go up, according to the mercury device of measuring our blood pressure. Okay. Now, what's this? Okay, kilopascal, right? And Pascal. Okay. So, this one is driven by Mr. Pascal in the discovery of pressure. Okay, things like that. You get the point? So, he said that the constant pressure of 101, okay, 325, okay, things like that, Pascal, is equal to 1.013 kilopascal. So this is also equal to 1 atmosphere. Now, if the rating of your pump or motor is in Pascal, it's very easy to convert that to atmosphere or to bar or to PSI later, even if you close your eyes. Okay, the point, things like that. Okay, now, we have here PSI. P stands for pound, S stands for square, I stands for inch. So square inch, meaning to say you double the inch for 2 times. So inch times inch is equal to inch raised to the power 2. And that's why inches squared. So pounds per square inch, because the per means division or fraction in elementary math. Okay, that's the point. Now, bar. Bar is not exactly the same as 1 atmosphere, to be strict. Okay, this is 1 atmosphere is equal to 1.013 bar. Okay, there's point something. Since in our calculations in engineering, it looks like negligible to consider because point something, that's why our professors and instructors dropped the point something during a calculation, but they never explained that. Then you also practice that until now, right? So we need to say, we need to be precise, really. 1.013 bar is equals to 1 atmosphere. So strictly speaking, they are not equal perfectly, but almost equal. Things like that. Okay. Now, 1 bar. Matapos na sa 1 bar. PSI 14.7. PSI is equals to 1 atmosphere. Ganon. Now, torr natin nakita sa problem. Kung saan natin yung torr run? Okay. So, torr is very less, I think so. Okay. 1 torr, okay, how much atmosphere? Okay. So, let's convert. Okay. 1 torr, how much atmosphere? Okay. Now, in every 1 atmosphere, there is 760 torr. So, technically speaking, if you have 1 torr, we have also how much atmosphere? So, we need to put that in the denominator. So, 760 torr and 1 atmosphere cancel the torr. So, you need to divide that. Okay, so 500 divided by 760 mo na itong atmosphere. Why? Because your unit of pressure is not compatible with the units of your solubility, that's constant. Okay. Siling ani ka salbahis ang mga problem solving sometimes in our examination. Okay. Divided by tuyuon June. Okay. So 0.658 para maka-convert na yun. Okay. Diba? 0.658. Okay. So 0.6. All books are using torr. Usually. Okay, so 0.658. So 0.658 atmosphere. Okay, it's equals to 500 torr. Now it's easy now to solve this by formula. Take note. What is the solubility at a pressure of 500 torr? So there's no final initials. We cannot use P1 over P2, is whatever it is to, like that. So we will use the basic one. So solubility of a gas in a solution is equal to the solubility gas constant K, or the Henry's law constant, times the partial pressure of a gas in the solution. Okay, so we are asked for the solubility. X, K, kani siya, solubility gas constant. But actually guys, directly substitution lang din siya guys, no? So this is the way, because if we try to go directly to the complex part, so it looks like confusing, right? Okay, mole, so going down, liter, and atmosphere, then, okay, times pressure, okay, which is 0.658 atmosphere. Cancel the atmosphere. Okay, what we left here is moles per liter, meaning the unit of your solubility. It's really concentration. Okay, things like I told you over and over again. Okay, 0.658 times 1.5 exponent to the negative 3. Now we have 9.87 to the negative 4. Kasama niyo siya guys, so 9.87 times 10 to the negative 4 our moles per liter of this particular solubility of a gas, which is not mentioned. General. It is mentioned CO2, ammonia, blah. Okay? So moles per liter is also capital N. Molar. Okay. Molar per liter, also known as molar, or use capital N. That would mean the same. Okay. Things like that. We maximize only the total understanding. We need to point things like that. Okay. So we go to problem number 3. So problem number 3 is taken from Chemical Engineering Board Examination. What's this? 2013. May. Ako siya nag-research. Okay. So, which among the substances, which among one of it is highly soluble in water? There are questions like this, guys, that is very difficult to analyze if we don't have foundation. Okay? Basic foundation of the topics. For example, A, hydrogen gas. B, carbon dioxide. C, okay, sulfur dioxide. Okay? E, none of the above. And how can we do this? Okay, the first thing to do is first according to molecular weight, second according to intermolecular forces, third according to the covalent bonding of the electrons being shared or not, polarity or non-polarity. Okay, so there's a lot of bases to consider and choose one. It's very easy to choose the molecular weight, right? But sometimes there's an exemption. That's why be careful not to use all the time the molecular weight. Okay? But under normal circumstances, molecular weight is okay to consider. Okay? Things like that. Okay. Ganon. Okay. Let's explain. Okay. Letter A, H2 and H, right? So then H, single bond H. So all the electrons has been shared. Right? So meaning to say, if you try to react this to another substances or water, it will never react anymore. So it will not be soluble because there's no electrons remain to share. Right? So H2, hydrogen gas, it's not because that's non-polar. All electrons have been completely shared. So that is non-polar or undergo the non-polar covalent bond. Okay. Now, CO2. CO2. So, CO2 stable or not? Okay. So, when we mean in chemistry, guys, we always attribute it with electrons. When we say stable, polar, non-polar, like that, okay? We can distinguish the characteristic of the substance or element, okay? Things like that. So, carbon dioxide. Oh, we have parent carbon. Okay. So carbon have so many isotopes. It will exist as a graphite, diamond, anthracite. Okay, things like that. And sometimes due to byproduct, it will yield also bitumen or asphalt. The black color used in the road, it's mainly composed of carbon atoms. You get the point? Because naturally the color of the carbon is black, just like an ashes after burning process. Okay, if you burn all the branch of the trees, it will be black. If you burn the sugar, it will also turn black. So visually, the appearance of carbon is black. Okay, that's why also the road is black in asphalting. So unless you will paint that with green, it will become green. Okay, with the point, things like that. So carbon and two oxygen here, no? Oxygen, oxygen. Valence electrons. Why, guys? Because it is the valency that would determine really the chemical and physical properties of all substances in the planet Earth. That's why we need to deal with the valence electrons. You get the point? So, mo siya hinungdan dyan, makabauta na, stable, reactive, toxic, poisonous, things like that, okay? You get the point? Okay. So, carbon. 1, 2, 3, 4. Oh. Okay. Octet rule. Review ha, octet rule. There must be at least or maximum of 8 electrons shared. It will not go beyond or else you will defeat the rule. Okay. So, oxygen 1, 2, 3, 4. 1, 2, 3, 4. Okay. How can you interpret this? Carbon dioxide. Carbon dioxide, okay, is generally polar. Okay, generally polar with respect to carbon, but also specifically non-polar to oxygen. And then after that, you will see the overall. So the overall is non-polar. In your overall analysis for this regarding polarity and non-polarity, it's not on the attachment. It's in the parent element in the center. Now, if the parent element in the center carbon will completely share, that's meaning this is really polar. The completely share, non-polar. Non-polar man ang covalent bonding, so equal sharing of electrons sa carbon. So meaning to say, CO2 is non-polar compound. Okay, meaning to say, flammable. It's easy to burn. Lower boiling point, like that. It will be ignited easily. Okay, and conducting electricity once it is non-polar, just like hydrocarbons characteristics. Okay, flammable. Okay, get the point. So that is the way how to distinguish. Okay. Now, SO2. Okay, so meaning to say, if the carbon is non-polar, so there's no way for carbon to react with another compounds because the carbon is the actor of that compound. It's not the oxygen. Oxygen is just attachment. It's not the parent or the background or the core element in that particular compound. So, non-polar siya. So, the more it is non-polar, the more it will not be dissolved. Right? Okay. The more it will not be dissolved to water, so we need to say hydrophobic is the term for that. Hydrophobic substances will not be dissolved to water. Okay, and hydrophilic substances are those substances that will dissolve to water. Okay, for example, if we have, let's say, fat. Okay, the fat, things like that. Then the head and the tail. The head of the fat is not soluble to water. And the head of this fat is very dense, meaning very weight. So, for example, if the baby will come out from the vagina, the head of the infant will go first, right? The same also with other substances in our body. The head, for example, sperm cell, the head of the sperm cell will go first in moving chupa-chucho, like that, okay? So, now, hydrophobic to water. Do you think it will dissolve easily? And it will go up in our system? It will remain in our vital organs. So that's also the reason why fats will be developed. Because the tail is the last to move. Because it has a very less density compared to the head of that particular substance. So if it is the reverse, then wala siya problema, okay? There's no such, too much high cholesterol, there's no fat people. But the sad thing is, by natural really, it's the head of the fat or the lipid family that is hydrophobic to water. It will never be dissolved to water. Okay? Kining mga fats. That's why the oil will establish layer if you try to mix that. Okay? Because all oils are fatty acids under the fats family. Okay, COOH. So that's why it will produce layers. And then the one will go down is the one with a high density. And the what, okay? You get the point? And the less dense will go up. Ganon. Na i-compare din mo ang oil. So get the molecular weight, collapse. And the one who have higher molecular weight, of course, it will suspend to the bottom part. Okay, so your solution there is called suspension in chemistry. Okay, when you have separate layers. So there's a lot kasi colloid, suspension, ganon. Okay, so residue, precipitate, kaloka. Okay, things like that. Colloidal suspension. Okay, homogeneous mixture, heterogeneous mixture, ganon. Okay, so ang SO2 guys is non-polar. Okay, ang sulfur, okay, 32.2 atomic mass or 32.2 AMU, atomic mass unit, or 32.2 mass number. Okay? Then, if you try to calculate the molecular weight, it's a 64 something, no? Okay, grams per mole, which is higher than H2 and CO2. That's why it will dissolve fast. And aside from that, polar, there's a lot of electrons unshared in the oxygen and also in the sulfur. Okay, so both have, unpaired electrons. Okay, now if you say lone pair, guys, meaning 2 electrons counted as 1. So 1, 2, 3, 4, 5, 6, 7, 8, 10 unpaired electrons, 18 unpaired electrons divided by 2, that's 9, because pair means 2. Okay? Anak siya of lone pairs and electrons. Okay, ganon. Things like that. The answer for this is sulfur dioxide. Okay, that will trigger the production of hydrogen sulfide. Okay, so number 4. What mass in grams of carbon dioxide in 500 ml of lemon lime soda? Kamatay ko eh. Okay, that is under pressure of 350 atmosphere. Kakaloka. 25 degrees Celsius. Nalubog-lubog na po do. K is equals to 3.34 times 10 to the negative 2. Okay, molar per atmosphere. Okay, now, there's a lot of given. It looks like complicated, but it's easy to solve. Okay, like that. Okay, the technique is follow first the rule in the formulas. Okay, later, the variance of how it is being set into complexity, like that. As long as you follow first the basic requirements, then don't force. If the given will not be there in the formula, don't force to really substitute all the given, because it could have been the other given data, there are decorations. Okay? Or conditions only to attain that particular data. Okay, things like this. Okay, say, what mass in grams of CO2 in 500 ml of lemon lime soda? So our solution is lemon lime soda. Meaning there's carbon dioxide, there's water, there's ascorbic acid, vitamin C. There's also citric acid. Because the moment you will say lemon, there's citric acid. So there's a lot of solution for this. And there's also lime. Okay, lime for the soda. Okay, things like that. I get the point, mga palangga hugitan. Yeah, ganun. Okay, now nasan siya carbonic acid? Because naman CO2. The moment CO2 and H2O will be combined, it produces H2CO3, carbonation, or carbonic acid. Right? Okay. Now, sa nato. So, gipangita ang mass in grams of CO2. Okay, question. We have volume 500 ml. Okay, and then this is the volume of the lemon lime soda. Okay, under pressure of 3.50 atmosphere. Okay, at 25 degrees Celsius. Okay. Solubility gas constant is equals to 3.34 times 10 to the negative 2 molar per atmosphere. Okay. Now, there's no final states and initial states. Don't use the P1, P2, S1, S2 like that. Okay. Use the only one. Solubility of the gas in a solution is equals to the solubility gas constant and the pressure of the gas in the solution. So we have the pressure check. Pressure. Solubility gas constant check. So get the solubility. You get solubility first, but then you can get the mass. Now, you will be confused because mass can always be involved in molecular weight and molar mass. You have a lot of options. So this is your first option, that mass will be involved. So in molecular weight, so molecular weight is equals to the mass over moles. So therefore, mass is equals to molecular weight times the number of moles. So this is equation 2. So equation 2, mass, molecular weight times the number of moles. And this is our target really, mass. We have the molecular weight, but we don't have the number of moles. Okay, so solve the number of moles, step 3. Okay, in your step 3 here, think of a formula that it will involve number of moles that link also with this data. Okay, so the basic requirement is go for the concentration or solubility is equals to moles per liter. N over V. N is the moles, V is the liter. So by this equation 3, you can solve the N. Okay, and put that here, and you can have now the mass. So N is equals to the solubility or S times V. Okay, then this is equation 3. So in this particular problem, you have steps 1, 2, 3 before you can solve for the mass. Okay, things like that. Now solve first for the solubility. Now take note, are they all compatible with each other? With the units? Okay, or not? Take note. Are they really compatible with each other? Okay, ano na yung paguna-muna? Okay. So, substitute na yun. Solubility is equals to the K mo na siya. So, 3.34 times 10 to the negative 2 molar over ATM. Now, do we need the molality here or the molal in our equation to convert the two other units compatibility? No, because we don't have molal beside the K. So we need to break this molar into moles per liter because molar is concentration. So moles per liter. Then times pressure, atmosphere. Compatible already? Yes. Atmosphere in the denominator. We can cancel now that one. So atmosphere cancel. What will be left? Moles per liter, which is the unit of solubility. Okay, now solubility is equal to concentration. The confusing part here is only for the student to understand. If they really understand solubility and concentration is just the same. The moment they cannot understand that solubility is not the same meaning with concentration, you will never answer this perfectly. Okay, because you know, we always noted C as a concentration, not solubility all the time in our chemistry. We use different expression of concentration. We never say different expression of solubility. But you know, at the time, our teachers will not teach us that concentration and solubility will not be the same. Will be the same, right? It's always concentration, 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 concentration. Until we reach in the 3rd year, like that, solubility na dayon. Okay? So, muna siya nitabo. Muna na ang gray part na ng area. Kaya solubility, ang S is different from C. Right? So you will say now, solubility is equal to concentration. Okay, now, so substitute your S into the concentration here. Okay, here, solve for the value of N. So N is equal to C Okay. C. What is C, Kanisha? I-compute sa ninyo yung C. Last problem ni guys. Okay? So, 3.34. Okay, 3.34 exponent negative 2 is equals to times 3.50 chuva is equals to 0.1169. So, 0.1169. This is okay. This is now moles per letter, right? Moles per liter. Then times volume. Do we have the volume? Yes, we have. But in milliliter, not compatible with the liter. So convert. That is 0.5. 0.5 liter. If you say 500, that's perfect because 1,000 milliliters is equals to 1 liter. So 0.5 times this 2.5 liter cancel, mole will be left. Okay, is that it done? Okay, after that, steps 3 pala siya, no? Okay, so 0.5 ganon times 0.116 na nga palangga, no? So we have 0.5845. Muna na mo, 0.05845. Then substitute that here in the mass formula in equation number 2. And molecular weight of this auto pila. Solve atomic mass 32.2, 32 plus 32.2, 64. Okay, 64 times 0.05845. Okay, we have 3.75 grams. Okay, things like ganun kay molecular weight alin niya. Okay, are we sure we are dealing with this O2? No, we are dealing with CO2. Okay, so it's not. Things like this you should be careful. Okay, because you are very, you are now in the mood of solving a lot, very eager, very excited, very happy, and then you will sometimes use the wrong compound such like this, right? I use the SO2 instead of CO2. Okay? Ganon. So it's better to correct by your rather somebody will correct you. But it's normal to get mistakes, right? Because, you know, I love unscripted vlog. Okay? Things like that. So, 0.05845 times, okay, 44 lang niya siya. So we have 2 point something, okay, 2.57 something grams of your CO2. Ganon na. Be sure guys ha, that all the units are incompatible with each other or else sayo, Jude. Okay, you got the point. Ganon. Any questions so far for this? So this is Henry's law discovered by Mr. William Henry in 1803. 18th century. Ganon. Okay. Wala natin question, no? Okay. Tomorrow, we will be solving the vapor pressure lowering and the osmotic pressure, which is very important in reverse osmosis process to convert seawater into pure drinking water. Okay? That the world now is using in different hospitals, such as Wilkins, like that. Okay? Reverse osmosis or whatever. Okay? Reverse osmosis through the use of semi-permeable membrane filter. Okay? And I give you the overview. The formula will be C is equals to RT. CRT. Pressure is equals to CRT, where C is the concentration, R is the universal gas constant, T is, I think, Kelvin. Okay. You get the point? Ganon. Okay. Bye-bye, mga friends. Hello. Bye-bye for our Henry's Law topic. See you tomorrow. Remember that Jesus loves us and I thank you. Char. Diba? Diba guys? Nakakaloka mga palagingging.